So today I would like to welcome you to our webinar. This webinar is part of the project Choice. For those who don't know, Choice is a European Union funded project by Horizon Europe, and we focus on integrating behavioral change and real-world decision dynamics into climate mitigation modeling across several sectors, such as food, agriculture, and land use. As part of this endeavor, with our valued consortium partners, EASA and SDSN, we have created two interactive online simulation environments that we called Choice ISE, that users can explore YAM scenarios related to food sector in order to better understand how specific policies, behaviors of consumers and producers, and in general food system choices can influence specific climate outcomes. So I am Nikos Tantaroudas. I'm a project manager of Choice. And today with us we have also Dr. Sibel Aker and Ryan Tan and Clara Duzal. So you can have a quick round of introductions for those who don't know us already. Sibel, you may start with yourself. Oh, I think you are muted. Maybe we can go with Ryan, and when you fix your microphone, we can come back. Okay, Ryan.
So I will try to speak on behalf, like I try to guess what Sybil is trying to say, and I'm going to pretend like like introduce both of us. So me and Sybil, we work in YASA, and we come from the ECE program, which is Energy, Climate, and Environment. We are part of the Sustainable Service System Group, and we both are working together on the FELiX model. So we are quite happy to be here to talk to you more about the tool and also a bit about the model. Yeah.
Clara?
Yeah, hi everyone. So I'm part of the Sustainable Development Solutions Network, SDSN, and at SDSN I'm working for the FABLE team, so within the FABLE consortium, where we've developed the FABLE calculator, and that is what I'm going to present today. So we work together with ERA to develop this ISE on the FABLE calculator, and the FABLE calculator is a model that we are using mostly in the FABLE consortium. Thank you. Now you're on mute, Nikos.
Yeah. Okay. Thank you, Clara. So the next steps will be to jump into the actual webinar. We will start with some introduction on the FELiX Integrated Assessment Simulator. Then we will have a short break for 15 minutes, and then we will jump in with the FABLE Calculator that is going to be presented by Clara. So, Ryan, the floor is yours to begin.
Okay, thank you, Nikos, for the really nice introduction. Let me try to share my screen. It works, right?
Yeah. Yes. Okay.
So let me just thank you all for coming. I'm really happy to share with you about the tool. I think every one part of the tool, like the tool, like this specific tool is created by YASA and ICCS, and we talked about the last year or so and worked quite hard on it. So we are quite happy today to be able to showcase what we have today. So some brief introduction to what the tool is about. So the tool is connected to the FELiX IM model, which is an integrated assessment model. So just think of it as is quite a very big model that is used for decision making, but oftentimes because it's so technically complicated or complex, it's very hard for people to have access or to actually play with it and explore it. So the whole idea behind it is to try to make it more usable for people and package it quite nicely so that more people can use it and it can be available for the masses to explore and answer questions that they are interested in. So specifically for the FELiX ISE, we want to explore the relationship between the food system and the impacts on different sustainability dimensions. But very specifically, we want to focus on the consumer perspective, because we realize in the food system that all of us are consumers, right? Because we eat food. So that is something that is important to all of us. So all of us have a part to play in terms of how we contribute to the food systems, and as a result, what kind of sustainability dimensions that we are affecting. So the way that we want to introduce the tool is more like we want it to be, we want to see the perspective of the normal layman, to think about what kind of behaviors they have, like for example, diet, or maybe the way that we manage food loss and waste. And we try to imagine a future where everyone behaves like us, because we all have our own behaviors, and if maybe for good or for bad, if the world behaves like us, what does this mean for different, I guess, environmental and social systems? So this is a kind of a nice way to imagine it, right? Because currently, right now, we all have different actions, different choices, but we have trouble trying to make sense of this on a bigger scale. And I think the nice way about the FELiX ISE is the way that we can try to imagine this on the global scale. So with that, this is the quick introduction of the FELiX tool. And for today's session, I would like to, the rough flow of it would be, I'll give a quick demonstration of the tool. And then during the session, there will be a bunch of small exercises so that everyone has a small chance to kind of play with it. And there's some exercises that are more interactive where you can share your scenarios and then we can visualize it on the screen. So without further ado, and also at any point of time, if you want to see the tool, the link is also in the Q&A or chat box. So feel free to look at it anytime too. So without further ado, let me enter the interface. So there's this big blue button, so enter application, and you have access to the tool now. Yeah, I will full screen it to make it a little bit bigger. So how this interface is being divided is we're trying to be a bit intuitive, where on the left side, there are your actions, and on the right side, there are your sustainability indicators. So don't be too worried about the different tabs, because most of the scenarios can be explored just with this page. So on the left side, we have a bunch of actions that can be relevant to us. So there's diet change, food loss and waste, and alternative proteins. So let me go through one by one with you. So if you look at diet change, there's a bunch of buttons, and all of this kind of gives a rough range of what possible diets that one could take. So for now, if you're quite confused with what this means, you can click this little graph preview, where you can see a little graph on in terms of what an average diet would mean. So to give a quick example, maybe, for example, you adopt a flexitarian diet. So a flexitarian diet is something that is, to put it simple, it's less dependent on animal food. So if you look at a small graph, you can see that the colorful lines at the bottom, the yellow, the orange, and the red, is starting to decrease. So this imagines a future in which that we are less dependent on animal food and we are more dependent on plant-based food. Yeah. So moving on to food loss and waste. So food loss and waste is right now on average, on the global average, is about, I guess, about 40% of all kinds of food produced is actually being lost and wasted. So these are not being consumed. And on different food categories, there's different amounts of loss and waste. Like, for example, you see vegetables and fruits is about 45%, for grains 30%, and for the rest, like different meat products, is about 20%. So this is kind of the distribution of the different loss and waste. So for example, if you press 20%, what that also means is that you halve the amount of loss and waste that you have. So that there's a kind of change that could happen. And finally, for alternative proteins, is I think it's something that it's starting to pick up. So what this means is like the kind of alternative foods there are right now. Like, for example, you see maybe almond milk, for example, or fake meat. So what it actually is trying to imagine is that currently now we depend a specific amount of proteins on certain kind of food. But what if we have a future where we are dependent on some sort of alternative technology, where maybe the uptake of certain food products like fake meat gets more and more? So for example, we eat maybe a kilogram of meat. Okay, that's a bit too much, but just to make the number nice, if we eat that much, and maybe a 20% means that we replace that with this alternative meat or this alternative technology. So these are quite relevant because it's starting to pick up, and it's also a nice way to explore like, what if we continuously try to, eat these food products. Okay, so on the right hand side, you will see 6 different indicators. So at first glance, you might wonder, okay, this is quite a bit of indicators. And my response is that I think it might be quite like a bit, but I think it's also quite important, because I think a lot, like when I talk to a bunch of some of the participants I had before, or like some maybe even my friends, a lot of them, like, I guess climate tends to be a very big part of how we see the environment, and I think this is not entirely accurate. And the reality of it is that the food system can be quite complex, and there are different forms of environmental pressure apart from just emissions. So the reason why we put these 6 indicators here is because there is a lot of nuance in terms of what kind of environmental pressures we have. And it comes from different forms like land, climate, fertilizer, biodiversity, and water. And also there's a social indicator, which is nutrition. And I think this is quite a more holistic way of understanding what is the sustainability challenge with food, because it really is like that. And even though it might be a bit overwhelming at this point, it's really important to see that there is these challenges that we have, and these are actually really relevant to the discussion we have in whether or not it's in policy, whether in terms of international development. All of these are actually really important. So yeah, so these are the indicators we have. And it's also good to point out that these indicators are aligned to things like the sustainable development goals, and also like the planetary boundaries. So yeah, so to maybe go through quickly what these indicators mean. So for land, we use the indicator of agricultural land needed, which is more or less the land demand. So for example, if we need more food, we definitely also need more land to basically have livestock or the different crops. For climate, there will be the greenhouse gas emissions for agriculture, food, and land use. So this is more or less the emissions that come out from a broad range of things within the food systems. And even like the different kinds of gases, it's not only CO2, there's also methane and nitrous oxide. So it covers quite a range of greenhouse gases. And for fertilizer, this is important because fertilizer is also one of the different indicators that also shows basically affects things like pollution and biodiversity. So this is a good indicator also to show, like, in terms of the, I guess, the biochemical like flows in the environment. And for biodiversity, this we measure this based on mean species abundance or biodiversity intactness. What this number means is that, for example, 100% is, imagine if the biodiversity is left untouched. And if it decreases, it means that the number of species that we have is slowly declining, which is the trend that you're seeing now. And finally, for water, this is the amount of freshwater withdrawal we have for food. So freshwater withdrawal, we extract it from things like groundwater or whether rivers, and these are all important for food production. We need to irrigate our crops. So this is freshwater withdrawal. And finally, we also have this other indicator, which is undernourishment rate. I mean, you can see it as nutrition, also as a form of food security, that we have food supply, but if some people are not able to access like certain food, or in general we didn't produce enough, undernourishment will increase. So there are people who do not have enough access to calories. So these are the 6 different indicators that we have. And right now, if you don't understand maybe what the numbers could mean, we also added this little target, which these targets kind of give you an impression on exactly how much change is needed. So what I mean by this is that, okay, let me give you an example, that we have this target here for biodiversity, which is aligned to the global biodiversity framework, which is an internationally agreed upon target where they're trying to aim that by 2030, there is no further loss of biodiversity. So with this little green square, we are trying to bend the curve into this little green box. So if the numbers are a little bit overwhelming, I think it could be also nice to just think of it as a behavior exercise where we are trying to bend the curve into a kind of safe operating space. So yeah, and some of these indicators, some of them are based on international agreements, but some of them are also, I guess I would call it a bit more normative, because things like how much emissions that we should have for agriculture, food, and land use cannot be easily decided. So some of these are, based on IPCC reports, where I guess a lot of the researchers believe that, this mitigation potential is really possible under low cost measures. So this gives kind of a good idea of exactly what can be done and what we should maybe aim towards. Yeah, so this is a quick overview of most of the targets. And to explore further, for example, when you have a sample scenario, I'll just click any random buttons right here. For example, we now have this scenario and we want to explore further into it. For example, we see that, the gray line represents what it was before, if the business as usual situation. And now we see that with the new scenario, for example, it decreases. And the way that we can try to look deeper into one of the indicators is to, hover over the graph and click it. So when you click it, what it does is you are transported to this, a relevant, I guess, systems tab, where, for example, if you click the climate indicator, you go to the climate tab, and then you start to view you have access to more relevant graphs that could explain why this behavior, this indicator behaves like that. So yeah, so this is one way that you can start to explore. Maybe you start from a systems perspective, and then you start to explore individual subsystems to understand why this is the case. Yeah. So right now, if a lot of this is quite difficult to understand right now, there is also one way to, to improve your conceptual understanding of the food system. And on the top right-hand corner, we have this interactive lesson where we together can build a systems map to make sense of how, our different food actions can relate to the sustainability challenges. So maybe I'll click that right now and give a quick presentation of it. So on the top right-hand corner, there's this button called interactive lesson. If you click on it, you're transported into this pop-up. So this exercise is to really, start step by step to understand, okay, this is the starting point of our food demand and how it eventually affects the different systems. And the reason why this is important is because we also need to realize that these indicators are not, these systems do not act alone, right? Because, for example, there's a lot of interconnectedness between the different systems. One of the examples would be, you saw that fertilizer increase also has an impact in terms of biodiversity. It also has an impact on climate, for example. So a lot of these systems are always interacting with each other, and this building of the systems map help to really conceptually, understand how these are being, on how these are being, how what kind of interactions that exist. So let's start with this systems map building exercise. So at this point, if anyone doesn't really understand the notation that we have, so a quick description of it would be, if you see an arrow, what it means, it refers to a specific causation. So if you see an arrow with a plus, what that means is if population increases, food demand also increases. So it means a positive relation. But also it works the other way around, where if the population decreases, food demand also decreases. So you see, it actually works both ways. And the negative link, it's not in this systems map right now, but a negative link represents a negative relationship. So if there's a negative link, what it means is if population increases, food demand will decrease. Yeah, so this is more or less a very short, it's quick, but it's also short, way to understand the systems map. And for the loops, I don't think I'll go in detail, but I'll try to explain as the map is being built. Yeah. So to start it all, food demand is where a lot of the things start from. So for example, so food demand over the recent years has been increasing. And there are two main reasons for it. One of it is that we had quite a bit of population growth. And the other reason is also because there's an increase of affluence. So this is measured by GDP per capita. And this overall increases the amount of food demand we have on the food system. And this food demand is translated into production. So in a way that the two main things we need for food would be fresh water and also for agricultural land. Water for the crops, also land to farm the crops. Yeah. So moving on, if you take a look at the freshwater requirement, so we need fresh water, but we also have to act upon it. So how that works is that this loop represents like, okay, so I have a freshwater demand. I will start to extract fresh water, and I'll continuously do it till I reach the point that I'm able to meet the supply that I need. So this is where fresh water is being used. And the next graph, or the next diagram, like this is also the same for land. So every time we need more food, we also need more land, and this creates a sense of land pressure. And when that happens, we will need more space to plant more crops. So one of the things that we do is deforestation, and we need to deforest so that we have more space to plant our crops. And this becomes a cycle until we have enough to have the amount of food production that we need that goes into the food supply. So this becomes a loop by itself. Next, what happens if we don't have enough land? This is where fertilizer comes in, because we cannot expand land infinitely. So this is where we try to focus on productivity. So whatever that we cannot keep expanding for land, we try to increase productivity by fertilizer. So this means more yield per hectare of land. So as if we can't keep expanding the land, we also try to increase the amount of fertilizer to boost crop use in order to meet the food supply that we need. Yes. So moving on, this is the kind, previously we talked about, I guess, the perspective of the producers, but there are also consequential impacts of the kind of activities that we do. Like, for example, this biodiversity loss is driven quite heavily by food production in a way that, for example, if we put more fertilizer, there's a large part of the fertilizer that doesn't get absorbed, goes into the water. And this causes a form of water pollution, which affects the biodiversity intactness. Also, for deforestation, it should be quite straightforward that if you kill the homes of animals, they're not going to last, basically. And all of this have a long-term impact in terms of how much crop yield you can have. So there is a certain feedback with this. Next would be the greenhouse gas emissions. So there are a lot of different activities of food production that also causes greenhouse gas emission. So let me go through one by one. One of it would be agricultural land use. So these are the kinds of things like, for example, if you raise livestock, you have a bunch of cows, you also have, for example, if you plant rice, all of this has methane, production of methane and release methane into the atmosphere. And for deforestation is that a lot of our biomass or a lot of our trees kind of they contain a lot of they store a lot of our carbon. And if we cut it, you can't store it anymore, and then it gets released into the atmosphere. For fertilizer use, some of the, for example, nitrogen that we use also gets, it also gets absorbed into the atmosphere. And that's why all of this contribute to greenhouse gas emissions. And because, if you increase emissions, you also cause more warming. And then it also have a long-term impact on biodiversity and the amount of crop use you have. So there is also a feedback back into the system. And finally, we also have the last feedback, which is also with food supply. So, after all of this, if food supply is not enough, there will also be undernourishment. So with more if there's undernourishment, this also affects the food demand in the long term because it affects how much food people are able to consume. So this is a rough idea because just now I showed you 6 indicators, but I didn't now with this diagram, it can be a little bit more obvious that it's not that straightforward, that all of these systems have interact with each other and the results are not as straightforward as one might imagine. But also another way to see it is that currently, we only explain food demand in terms of GDP per capita and population. But in reality, this is not something we can, like, for example, we can't affect population, we can't affect our affluence, but what we can change is our food demand in terms of our food behavior. So what we can I guess we can influence this whole system by different kinds of actions like diet change, food loss and waste reduction, and alternative proteins. So right now, the focus of this exercise or this workshop is mainly to explore how this food behavior will affect all the different systems. And you can also try to learn a little bit more about yourself, a little bit more about the world, and hopefully maybe this will inspire some change in everyone. So let's press finish, and then we're done with this lesson. So I hope everyone is still awake and with me. But now we will start our first exercise. So I want everyone to maybe enter the tool, and for the first exercise, we will teach everyone to build their first scenario. So right now, when we were building the scenario just now, we were mostly clicking the different buttons in order to make that represent our actions. But truth be told, I understand that this doesn't make a lot of sense to everyone. Like, no one really knows what a healthy or flexitarian diet is. So what we put into this tool is that we can click the survey button, and instead of clicking, I guess, the diet that best represent you, you can actually answer a series of questions. And based on how you answer the question, the tool will give you a best recommendation of what your current diet is. So I think this first scenario could be nice to understand exactly, I guess the impacts of your current diet, for example. So I would like to invite everyone to maybe take 5 minutes or to 10 minutes to go and click this survey button. If you look at the navigation bar on the top left-hand corner, you have this light bulb that says build your first scenario. And I would like everyone to try and build their first scenario and observe the outcomes of your behavior. Yeah. Could everyone do that right now? So, okay, so maybe let me continue with this. So I think it's fine at this point, and not like if you have managed to find time to explore the different systems. But if you haven't, it's fine. I can also give a quick demonstration of exactly how one might be able to look and explore it. So let me give a rough idea. I've done the survey by myself. I more or less fall in the healthy and alternative proteins kind of diet. I mean, I could also make you guys share your scenarios, but I don't want to put anyone in the spotlight, especially after seeing that some people are a bit maybe demotivated by their own actions. But don't worry too much about it. So let me quickly maybe go through my behavior. So for example, my behavior is like healthy, which I'm willing to reduce a bit of my meat consumption, mainly for health reasons. But I'm also like willing to have some alternative proteins because I'm a big fan of the vegan, like that dinosaur nuggets in the supermarket, maybe. So yeah, so this is roughly, I guess, my behavior. So let me go through some of the indicators to show how I have understood this. So for example, when I click on land, on agricultural land needed, when I click the graph, I'm transported into the land use module, and I get to see the different compositions of what kind of land is needed. So as you can see from this graph, right, the amount of grassland has slowly declined after a certain point. And this is likely because of how my diet has become less animal food reliant. Because, if you need to farm, like, for example, beef, a cow needs a lot of land. And also on top of it, you also need to feed the cow like some feedstock, like some grains. And this also requires a lot more land to produce a single calorie of food. So in some sense, having this so basically with this graph, you can kind of have a guess in terms of how the different actions relate to this land use. So moving on, maybe let me look at climate. If you see for climate, there is a decrease in the amount of livestock and manure. And this is also largely attributed to the amount of livestock there is. Like, for example, when I go to a less meat-related, animal-related diet, you see a fall in terms of the amount of methane emissions from livestock and manure. There are also a lot of other changes. Some of it remain constant. Like, for example, the ones for agriculture, yeah, some of it remain constant. Another change would also be maybe there are lesser methane emissions from rice cultivation. So this is also maybe a shift in terms of a slightly less dependency in terms of grains, or it also could be because for a healthy diet is less dependent on also for grains, it's a lesser grain consumption. And quickly for fertilizer use, you start to see that with this new diet, you see that there is a lesser amount of nitrogen application because of the grains. And if I push it even to a flexitarian diet, you will see a bigger decrease in terms of fertilizer use. So what this means is also that for a large part of fertilizer use comes from grain production. And in the case of moving to a more, I guess, less animal food dependent diet, you also reduce the amount of fertilizer use that is required. Yeah. And maybe quickly to move on to biodiversity. For biodiversity, there are different causes of biodiversity losses. And the way that we have seen it is there are four main drivers of it. One of it would be fertilizer consumption, which is the situation where if you put too much fertilizer, it gets run off into the water and you start to pollute, aquatic ecosystems. And other kinds of impacts would be climate damage, which is basically like the amount of the effect of warming, and also for biomass production, which is also agriculture activity. And one of the biggest driver would be land use change. So this is the effect of if you keep destroying the habitats of animals, the result is that there is a lot of species loss. So you can see that, if you go towards a healthy diet or more alternative proteins, where you're moving away from more livestock farming, or maybe there'll be lesser need for land use changes. And as such, there is a slight change in biodiversity intactness. And finally, for water, freshwater use, you see that there is a bunch of things that's going on, right? Because, for example, you reduce the amount of need for grains because you need lesser feedstock for animals, but yet at the same time you increase a greater demand on other crops. So I know that the other crops is not very explanatory, but other crops involve like oil and sugar crops. So what this does is that because of the new change in diet and alternative proteins, especially because alternative proteins are quite dependent on oils as the inputs for alternative proteins. So you start to see a shift in terms of what is needed for fresh water from one category, which is grains, to other crops. But overall, if you see on the right, there's not much change in terms of fresh water withdrawal per category. But this is how it is. And finally, for nutrition, there is a slight benefit in terms of prevalence of undernourishment. And maybe to explain more in terms of how prevalence of undernourishment works, if you see the graph on the right, so this is how it's being modeled. So for example, all of us have different calorie consumption, and it shows in this distribution curve. So if you see the peak of it, it means that on average, all of us, not all of us, but we have an average of maybe 2.5 thousand calories per day, which is quite a healthy amount. But there are people that are not so well off, and they fall below at the lower end of the curve, which is around here. And you see there are some people that are also consuming a lot more than they need, which is quite crazy, like 6,000 calories a day. But there might be people who do that. And how undernourishment works is if you draw a threshold, this is the line where this is the minimum amount of calories you need to be considered nourished. And unfortunately, there are some people that fall below that line. So this area of the curve represents the amount of basically undernourishment that happens. So you can see that because we change to, I guess, a more healthy and flexitarian diet, because you are more dependent on plant-based food, there is a greater amount of basically you can produce more because it's a lot more efficient, and also it's a lot more accessible for people, right? Because if you produce more crops, more people have access to them because could be a little bit cheaper, and then more people will be able to have access to food. So quickly, I will just click between average and maybe flexitarian, you can see that the curve changes a little bit. Where when you see the curve being squeezed, it means that there are lesser people on the two ends of the spectrum, where it means that people who are undernourished have more accessibility in food. And overall, I guess the average calories do not change by too much. Yeah. So this is a quick demonstration of how I went through each of the systems and roughly have kind of a guess to figure out exactly how my behavior has affected the sustainability outcomes. So to quickly, wrap this up, we also have this one last exercise that is serves as a thought experiment. So I would like some of your cooperation. If anyone has maybe a certain when you build your scenario, you're willing to share it. I would like to visualize it on the screen to make a kind of the thought experiment for everyone to have. So if anyone is comfortable with sharing your scenarios, please do so in the chat section. Anyone willing to, oh yeah, I forgot to explain how you can share your scenarios. Sorry, when you finish finishing the survey, you can press this little button on the navigation bar called copy scenario. And then it should have a little symbol that says copy to clipboard, and then maybe paste it in the chat section. So something like, if I have healthy, this, I'll copy. Yeah, that makes more sense. Sorry, I didn't mention it just now. Okay, so let me just include some of us. Okay, so okay, so there's another nice feature of the FELiX tool where instead of only seeing one scenario, you can see multiple scenarios at once. So if you click this top left-hand corner, a multi-scenario mode, you become into this special mode that you can actually put multiple inputs inside. So let me copy maybe Beatrice. Paste it here. Oh. And then I copy Lezama. I mean, thank you all for volunteering your own scenarios, but I can't put that many, unfortunately, in the tool right now. Okay. So this is this is Beatrice, the purple one is Beatrice, behavior, and the orange one is Lezama's behavior. So the point of doing this, right, putting them up on the screen, I'm not trying to narrow people down and guilt trip everyone. It's not my intention. But I want to ask a quite interesting question, right? Because I said initially with the problem statement that here are our targets, and here is what our behavior can do. And you can see that some of the indicators, we have met the target. Like for example, for land use, we can see that, for example, in Beatrice's behavior, we more or less has met the target for land use. But for others like climate, fertilizer, nutrition, fresh water, we have not actually met, the green box. And I guess the question would be, yeah, I would like to ask everyone, why do we still, as a lot of scientists still advocate that we should have behavioral change? What is actually the purpose of it? I would like you to have after seeing all these results, have a kind of a reflection on why is it important. Yeah, maybe a minute or so. Has anyone come up with any ideas on why this is still important to change your food behavior? Maybe you can write it in the section. If no one replies, I can also tell you the answer. Okay, I can quickly give a debrief. So actually, if you think about what these numbers represent, right? Think of it this way, that even though for climate, for example, right, we have not met this target, which is here. If you actually think about it, We have not even brought in other kinds of approaches. Like, we have not even talked about policy. We have not talked about technology. And even without all of this, we already are almost halfway there. And if you think about it, it might not seem like this is a lot, but I think that this is quite a lot because, we just purely based on what we can do as consumers, we can already do a lot of work that, that we don't even have to start on technology yet. So actually this contribution to the overall sustainability challenge is actually very big. So to kind of demonstrate what I mean by this, right, is because whatever actions that we have now are only demand side mitigation solutions. So it's only consumer actions. What if, we imagine a future that, in other sectors outside of, maybe even outside of food, maybe energy and all the other stuff. Imagine if we, for example, we have a future, so where there's this lever under external drivers that is called social economic drivers. And if we imagine a future where, for example, it's more optimistic, where there's more global cooperation, there is more widespread change, and if for those people who know about this framework, it aligns with SSP1. And if we click this, we show that actually the change is a lot more massive than that, right? Because you can see that the curve even bends down further, where if there's a future where technology tends to be more efficient, where we have less geopolitics and we are more cooperative, the future is actually a lot more, it's a lot more brighter than we see. But it's also very important that this amount of change is needed. Whatever it is that we have for our food behaviors is definitely needed in order to reach our final goals. And every single part is important. And this is why that even though it doesn't seem like a lot in the overall battle to keep ourselves to reach the sustainability goals, is very important for us to have this food behavior change. Yeah. And also another thing that I think most people would kind of undermine, I won't say undermine, but it tends to be forgotten, is that maybe it's not very apparent with the graph that we have here. But if you go off to the trade-off diagram on the next tab, if I put this on a spider plot, one of the things that maybe is quite important is that all of the scenarios, whether or not we are talking about Beatrice or Lazama's food behavior, we realize that effectively all of these indicators are being improved and you don't see any trade-offs. And I think this is quite an important point to make because, to put it quite simply, now we live in a very complex world that there is a lot of trade-offs. Like, for example, we have this situation for fertilizer use, right? Where initially the reason why farmers put more fertilizer is because we do not have enough land to expand on, which is good for our food supply, but the end is bad for maybe our biodiversity or land use, for example. So if you think about it in that way, a lot of technology and supply side solutions tend to always have a lot of trade-offs. And for basically using behavior, we don't need to actually navigate any trade-offs, and we can also improve all the different sustainability challenge in a positive way. I think this is actually quite powerful because honestly, it's not very common to be able to do things like that. And this is why I believe that behavior change is still very important if we want to meet our sustainability goals. Because this is really important. So I think I come to the end of the exercise, and I think it was almost about time's up. It's about 2:25. I would like to, I think as we do the exercise, I can see that some people are getting a bit pessimistic with how it is, and I'm trying my best to also say that actually it's not that bad, but we need to be committed to believe that our actions actually matter. So I hope that with this session, we can kind of have a balanced perspective on our food behavior. On one hand, it matters that it actually really does matter that we change. And it also, put things in perspective that not only that we have to change, our food system also has to change in a way that we can meet our overall sustainability goals. So with that, I think I will thank you for coming and staying for this whole 1 hour session. Thank you for your participation, and I hope you have a good day.
We can begin with the second session of today's webinar that is about the FABLE Calculator. So Clara, the floor is yours.
Yes, thank you, Nikos. Can you hear me well?
Yes, excellent.
Yes, perfect. Thank you. So I'm gonna do something similar to what Ryan just did, but on the FABLE calculator. So this tool has been developed in collaboration with Era and Dimitra, who's on the call today. So we provided the FABLE calculator, which is an open Excel model. So everything is based on Excel at the beginning. And this model is used to compute the evolution of agriculture, land use and land use change, and also consumption with flexible scenario design up to 2050. We use agriculture as the main driver of land use change. And so ERA on their side, they took this model based on Excel and they basically in some more technical way, translated it into Python and developed the interface so that we could play with the scenarios easily on this integrated simulation environment. So at the beginning, why was this FABLE calculator and not FABLE AAC developed? So it was back in 2017. And we wanted to have a simplified tool to model food and land use systems that was tailored to the local context. And with that, we also wanted to build local capacity to model complex food and land use systems. So that means that the FABLE calculator is at the country level, can also be at the regional level, so using an aggregation of different countries. And we have also some FABLE country teams, so teams of researchers that are part of the FABLE consortium that worked on the FABLE calculator to have it at a sub-national level. So it only depends on the data that you have available. So for a country, we would like to use national statistics, so a country to really change the data within the calculator, or if not available, to just use national data from global databases. It is being used, the FABLE calculator, to support decision making, to assess what should be prioritized, and also to facilitate cross-sectoral dialogues. And so to use that to build then a common vision for sustainable food and land use systems. So this FABLE calculator is developed for and in collaboration with national researchers within the FABLE consortium. And so that means that we build country or region specific modules. We also improve the FABLE calculator so that everyone, all the different collaborators, if they have a country or regional calculators, they always improve the modelization, but because of national context or regional context, we also can improve this model by developing specific modules. So for example, we were working with our partners in Denmark recently, and they wanted to have a better representation of peatland because they have policies in place where they want to re-wet peatland that has been drained to increase the cropland and pasture to grow more food and have more livestock. In the context of choice, we are looking at a specific population. So within choice, the South Africa pilot is having a campaign looking specifically at the youth population to see if could have a shift only for the, well, mostly for the youth population to healthier diets and see how they could reduce their food waste. And that's also something that could be a specific change in the calculator for South Africa, and then could be expanded to other calculators. But that's also something that could be represented specifically in the ISE for South Africa. So what is this FABLE Calculator ISE? So it's an interface that we use to use a specific version of the FABLE calculator for a country that is available on this ISE. So this, as I said, was developed with our colleagues at ERA. And it's been developed for 3 countries so far. So we started with Greece because Greece is a FABLE country team within the FABLE consortium. So we already had their FABLE calculator that was pretty stable. And then we worked from that to include new countries that are part of choice, so Spain. And then we added also South Africa. You'll see in the tool that you also have to select different scenarios you want to, well, you have different scenarios that you can play with, and you have the same parameters available for the countries. Those 3 I will say version of the tool are based on different version of the calculator. So we've develop things differently within the Spanish and the South Africa calculator, for example, because of the difference in focus within those countries. And so this ISE was developed because we wanted a web-based scenario explorer to use with the stakeholders, because it can be difficult for non-modelers and people that are not familiar with the FABLE calculator to test scenarios themselves directly on the Excel version of the FABLE calculator, because we have more than 25 scenarios that people can play with. It's a big Excel file, so you can get lost fairly easily in the model if you are really new to it and you don't have that much time to look into that. What is also good is that so I'm gonna dive into the IEC now. You should have the link to look into it yourself in the Q&A section of the webinar. But do pop a message in the chat if you cannot find it. So in this tool, we have also saved predefined pathways that you can play with. So if I start, for example, with Greece, so you see here that we have 3 options: Greece, Spain, and South Africa. If I start with Greece, the good thing is that the current trend pathway is one, and the global sustainability pathway as well, are 2 pathways that have been developed by our FABLE Greek team when we did an exercise, a global exercise of modelization back in 2023. So this is already based on stakeholder engagement and work from our team. This tool has already been presented, so some of you might already seen it, but it's been updated based on the feedback we received. And so the new thing are that, well, now we have 2 new countries. We've reduced the numbers of scenarios that you can play with, let's say, because it was considered confusing to have like the option to play with too many things. And now we try to improve the information that you can have to understand, well, what is a diet? How can it affect the results when I select different scenarios? You can also now compare pathways, so that's something that I'll show you later. Either you can use already prepared pathways here, or you'll see that you can also use the one that you've built yourself. To do that, you will have to use, a bit like Ryan shared and explained, you can export your current selection and then import it again. So either you can share with colleagues your selection, or you can also play again a pathway that you've already defined, because we wanted to avoid that you have to log in and give any emails and passwords to keep the pathway selection that you had built. We also are more transparent now on the other assumptions that are being used within this model, because the land use change and your food systems are not only driven by the diets that are being followed by the population, nor the share of food supply which is wasted. We have lots of other things that come into play, and we are now explaining in this fixed scenario pop-up windows what are the other assumptions that could explain the results, but that's something that the user cannot play with. But that could be something that is changed if one of the scenario is deemed like really interesting by a lot of people. But we want to avoid having too many available to play with, because it would get too complex. So here, if we look at Spain, let's say, you'll see that you have 3 already defined scenarios, pathways, sorry. So the current trends, where we have either no change in some scenarios, or the trend it changes is the same as in the historical period. In the sustainable consumer, you would have something similar to the current trends, but the scenario for diet is set here to eat Lancet average, and you also have some reduced food waste. And then we have a scenario on increased productivity, because it's a topic of interest in the Spanish pilot within Choice, where here you basically play with the current trends pathway, but you have some livestock and crop yields increase that are set to high growth. So then this is where you can select either your predefined pathway, or you can select different scenarios that you want to play with. And with that, you have the results that pop up automatically, and you can have a look at 6 outputs of interest in the FABLE calculator. So we don't only look at the GHG emissions and the land use change. So we also have a look at the nutrition and trying to see whether with our diet we are within what we call lower bound and upper bound of what is recommended in terms of total kilocalorie intake. We look at the land evolution depending on the scenarios, on how you could see, for example, some deforestation if your forest is decreasing, or you have a high afforestation scenarios if your new forest is increasing. If you're starting to eat a lot of meat that is pasture based, you would have an increase in pasture as well. And that's why you can have a look at that. We are focusing also on biodiversity, and the indicator we are using is land where natural processes predominate. It's a metric that we are using in the FABLE consortium that represent the areas where biodiversity can naturally flourish. And based on the different scenarios that you have, it will have an impact on this area. We are also looking still at the GHG emissions that come here on this graph. You can see at the aggregated level for land use change, livestock, and crops in CO2 equivalent. Here, this graph will only represent what is actually computed in the calculator. So, for example, if you are comparing with your CRT tables or national statistics at the aggregated level, keep in mind that some animals are not represented in the FABLE calculator. So this could explain some mismatches. And when I'm saying some animals, for example, it would be horses or buffaloes in Spain. That's not included. We are relying a lot on the FAO stats database. We also want to look with the FABLE calculator at some production statistics with the cost of agricultural productions in terms of fertilizer, labor, machinery, fuel, and pesticides. And also another important aspects would be the jobs. So the employment in agriculture linked with the different scenarios, split between crops and livestock, but also we have a dive into the different eat food groups because this is highly influenced by the diet that you are playing with. So I'm just gonna show you how what you can get when you compare two pathways. So we're gonna start with the current trends one and compare it with the sustainable consumer for Spain. So here, up. Wait, I'm gonna try it again. I don't know why it's not working. It was working 5 minutes ago. Okay.
That's always the case.
Yeah. Wait, I'm not on Spain anymore. Okay, great. Now it's working. So I'm comparing two pathways, the current trend and the sustainable consumer one. And here we can, well, my screen is maybe a bit too small so that you don't see the two different scenarios that are selected. So you can get usually the comparison of the two sections. But we can use this comparison tool to really compare what it means in terms of a different diet in 2050. So here we can see that by selecting the sustainable consumer pathway, we are getting closer to the minimum dietary requirements, but without over-consuming. We are eating a more healthy diet, so we are having more vegetables and legumes, and we are relying less on meat and milk. We can then have a look at the biodiversity results and see that with this selection of the sustainable consumer in 2050, my area of like land where natural processes predominate is way higher. This can be explained because some of the cropland and pasture can be freed up and returned into land that can support biodiversity because you don't need as much pasture for the animals, but also not as much cropland to feed the animals. And if we look at, for example, the GHG, here I have a reduction in, well, an increase in sequestration from land use change, but I have an increase in emissions from livestock and crops, which is weird. So I'm not gonna dive into that. I think it's something that we need to fix. Because with the scenario selection that I've done, it should be a reduction because I'm not eating and not producing as much livestock animals. If I want to do another comparison of, let's say, I could compare the sustainable consumer with here my increased productivity. I can have a look at land, say, and I can see that the agricultural production takes up roughly the same area, so the blue and dark green, but that the split is different because you need more land for pasture as the demand does not decrease in this increased productivity. And in GEG, so I'm gonna risk it again on this one. So what do we have? We have an increase in livestock emission and increased productivity. So it could be that even though you are eating more, you are more productive. The shift in the diet is leading to less emission in the sustainable consumer compared with this one. Okay, so if you don't have any question on how the interface is working, maybe we can start by doing an exercise that's a bit similar to what Ryan has done in the previous session, which is that you can create a pathway for the country you'd like. So you can start either with Greece, Spain, or South Africa, and look at the different results you'll get with this new pathway selection. Then you can export the pathway that you've created, or even several pathways that you like, so that in the next step, we'll be able to compare this these two pathways. So one of the predefined pathways, usually we use the current trends to compare the current trends with your own pathway to see what your pathway would mean compared to business as usual, let's say. So let me know if you have any question on how to create this pathway. And once you have created your pathway, I don't know if you can put it on the chat, because it's not like Ryan's where you create just some kind of URL. It would rather be stored as a text document, but you can always copy paste the text in the chat so that others would save it in another text document, and would be able to import it as a pathway.
Do we share the text from the pathway in the chat?
Yeah, you can. Ah, that's great. Does it say? Okay, so you use Greece. Okay.
Yes, I'm interested particularly in goats and the sheep, if it's. But
Yeah, okay. Um, okay. Okay, so maybe you can also try. So what I've done is I've took the text from Orestes in the chat and I've copy pasted it into a text document, and I'll try to upload it into my living version of the tool using the import pathway. So you don't see my full screen, but I've saved it into a text file in my in my computer. Okay. So Chris, that's it. Okay, and so what you can do is also create so your custom pathways, and then also compare this one. So with the current trends. So it's not only the one that have been predefined already, but the one that you are working with. And it's a bit slow on my computer today. I don't know why, but I hope it's running smoothly on yours right now. Have you managed to?
it takes time to load the results. It gets there eventually, but it
Yeah.
takes a bit time.
Okay. Okay, good. Have you managed to all import and export again pathway into the tool? That's the chat. So Dimitra, I see that it's also slow for other people. Do you think it's because we are too many on the platform at the same time? I don't know if Dimitra is here.
Can you hear me now?
Ah, yes.
Okay. Yes, probably because we are many users, or I don't know, when you try to import the scenario, maybe it has many spaces when you copy paste it, and maybe it
Yeah.
isn't handle this again. Maybe try to refresh
Yeah.
the page. I don't know.
Maybe I can try with the one I've created myself, so that it's not a copy paste, but if it's done directly with the tool.
Maybe try to refresh the whole page in your browser.
Yeah.
Oh.
Okay, yeah. So it's working. And now I got the one that I had created myself. Good. So that was the walk through the FABLE Calculator ISE. I don't know if you have any direct questions for me right now. As Ryan mentioned, we have a session to get feedback both for the FELiX model ISE and the FABLE Calculator ISE. So the two tools are not used for the same thing, as FELiX that was presented by Ryan is more at the global level. And the FABLE calculator is really at the country level, and the scenario selection could be tailored for the specific interest of a session where you would like to look specifically at, I don't know, livestock productivity, or diets where the options could be refined for a stakeholder engagement session on that topic particularly. Okay. Is there any questions? No. Nikos, do you want to go now to the session on feedback and discussion on the two IAC?
Yes, I think it's a good idea to proceed with evaluation.
Okay. So Ryan and I have both prepared two surveys. You have the link available on the Nikos put it back into the chat. So the first one is on the FELiX ISE and the second on the FABLE Calculator ISE. It's not in the same format, but if you could start answering the question specific to the two, so then that we can also have a discussion on your feedback.
And for those who are actually done with it, I would invite you guys to also, after you see your scenario, I would like you to choose one or two of the indicators. So just choose, all the different graphs that we have here. Maybe click one or two of them and try to look into, I guess, when you click upon it, try to understand, in the, I guess, the different systems tab to understand why this could be the case. So try to reflect a little bit, maybe in about 2 to 3 minutes. Try to reflect if you're able to find out what is the reason that your action has produced this effect.
Yes, so Rosa, the two tools are available online and free to use. And if you need specific directions on how it should be used for your student, you can contact either Ryan for FELiX and myself for FABLE. And I don't know if you have a particular country of interest, or if you are more interested in the global look at things, so it would rather be FELiX, and if it's country level, it would rather be the FABLE calculator. In the survey for the FABLE calculator ISE, there are a couple of questions on would you like to see any other scenarios that would be open for you to select and play with. And I got a couple of answers on having like the possibility to choose the population projections, but also the share of consumption which is imported and urban expansion. I don't know if anyone who selected these options want to elaborate on why that would be especially useful for you, because we would not always give the level of details you would be interested in, but if we know what would be the use for you, we can adapt and provide the option to select different level of parameters for this.
I put food import or recipes from Greece because in general, at least in Greece, we import a lot of things. So this goes together. It's it's the whole idea of food security, the idea of living within your means of whatever. So not avocado from Mexico or whatever. So I think it's a big thing, at least for developed countries. We tend to already developed. No, forget, scratch that. Greece is not. Anyway, you know what I mean. But we import a lot of things. So I would like to see this information somehow.
Okay. And would you be happy with something a bit broad on because so we represent, for example, 86 products in the calculator. So it can either be, well, I rely more on imports broadly, or would you like to see something where it's I rely more on imports from livestock product or
Broadly.
broadly? Okay.
Regarding them being somewhat autonomous or something like this.
Something like self-sufficiency or
Towards self-sufficiency, of course. Okay, I'm not saying that we should go back to closed borders or whatever, but to understand how much you are reliant on outside, to understand, not to cut outside influence.
Okay.
I also have a question, maybe also for like the respondents for the FELiX tool. I think one of the things that I was really reflecting about, and I'm really trying to make things happen, is to find a way to motivate people to, I don't have behavior change. And I think somewhere in the during the session, someone mentioned, if like they feel very quickly pessimistic about it because when they see some of their behavior, it really doesn't meet the goal that quickly. And I'm trying to find a way, because I still do strongly believe that behavior change is necessary, but I'm also trying to have a nuanced perspective on to what extent it works and how much other contributions we need from other areas of the food systems. But I'm also trying to figure out what is the best way to to improve, like how do I encourage people to make this change better, and also come from how can I embed this more into the tool. So if anyone has some sort of I get suggestions, or maybe the suggestions could be in the way I narrate or demonstrate the tool, feel free to to drop in a message or also say over the mic. Yeah.
Sorry, it's Orestes again. I was not pessimistic, but your explanation helped the explanation you gave afterwards. That look, this isn't a big change. Nevertheless, it's a good chunk of the positive scenarios of SSPs. I'm completing these surveys and these tools as I'm an air quality guy. Okay, so I'm a complete outsider in this whole process. But I needed this explanation to say, okay, if you add this to the other good things that we all hope will be happening, it makes a difference. That's it from my side.
Okay. So maybe also pointing to the order of how I explained it. So maybe it's like, maybe the target shouldn't be too like shown too quickly, and then maybe when you compare the change.
No,
maybe.
when you do the introduction with the box, because the box is very nice, the green box, we all want to go in the box. Say if we don't manage the goal, when you fulfill the scenarios, when you fill in the scenarios, don't worry, because this is just one part of the tools we have as humanity. I mean, something like this in your intro for the box.
Okay. I think, yeah, that's good advice. I will try to explain that in the narration better. Yes, thank you.
No, thank you.
Yeah, I think maybe it would be good in your tool, Ryan, which is like, it's great. I love it. If when you see in a box that you cannot manage to get closer to the target, that maybe it tells you, well, go back to the graph that explains the dynamics, and you'll see at which other scenario could lead to reaching it. Because, for example, I played with the scenarios and I selected a healthy diet with like I'm wasting no food and I'm replacing all the meat and like livestock product that I can have in my healthy diet by alternative proteins. But still, I will never get to the target for fertilizer and nitrogen applications. So maybe, some kind of some targets like that, it's difficult to grasp at how you could get to it. And maybe I don't know, a subsection of the graph that could explain, well, this is the other things that could, like, it's not you only that will get it to be achieved.
Okay. I kind of understand the perspective. Yeah. I'll try to think of solutions and maybe talk to have more feedback sessions on how to make it more apparent. Yeah. Thank you for that.
It's great.
We also have a comment for the FABLE calculator in the comments by Swani.
Hi, should I just unmute and talk?
Please go ahead.
I feel a bit overwhelmed. It seems like what you have is probably really advanced with probably huge amount of data which are able to render such calculation. I play a little bit with the Excel-based calculator, but I don't know exactly what to, I'm sure it can be used in many scenarios, but I just don't know how to start. I don't know if it's just me feeling this way because I'm seeing the tool for the first time, and I don't know so much about the methodologies behind it or the data set that builds up the methodology, or maybe this was explained earlier in the call, which my apologies, I didn't attend on time. Am I disappointing you by being completely lost here, but seeing that there's something that are potentially huge?
No, I think that maybe it means that we should include more information on what is the model that is behind this interface, which is quite complex, because it takes into account so many things. So it's an Excel. So if you're talking about the FABLE one, it's actually, yes, an Excel-based model behind it that's been translated into a Python code. And the data behind it is mostly FAO-stat data and other global databases that have been reworked to cover only the country that you are looking at in the interface. So right now it's only Greece, Spain, or South Africa. We have calculators for lots of others countries or regions. And usually it's being used either by researchers in teams to test different pathways and show the trade-offs between different policy actions, or it can be used in discussions with stakeholders to show them exactly what is the impact of choosing this or this scenario in particular. And then you have FELiX that would be used for different exercise and is more looking at the behavior change. Where in FABLE we also have lots of like agricultural practices, well, at least in the scenario selection that we give access to in this tool. So because I don't know like what would be your aim, like your objective, why you would need a tool like that within your research or work.
I'm building an app which help SME to plan sustainable paths. And I saw that you have a GHG calculator, but I don't know if this is the same as the scope 1, 2, 3 emission calculators. Because the example that are shown here seem to be rather specific to agriculture or perhaps in food and hospitality, food and beverages. So that I don't know if that means that the GHG calculator here would not be applicable to, for example, manufacturing companies, where GHG would be a heavy application. So I'm still trying to understand the basic applications of when to use this calculator and when not to use.
So the FABLE calculator, for example, covers the food, agricultural and food systems. So really at the production level, so in the fields, we don't really cover the processing steps that much. It's more really trying to look at the land use and land use change in the food systems. So I don't think it would be useful at your level.
Thank you.
Maybe one more thing I would like to bring up, because I thought this is quite an interesting point of discussion, that I think that a lot of like the way, for example, the whole idea of why we both create this tool is because we are trying to make models, which is otherwise quite opaque to most of the people, and we are trying to make it accessible to more people. And I think I'm very curious about the idea of like basically the credibility, because the challenge for us developers and modelers, we want to make it accessible, but yet at the same time we also have trouble not, we don't really want to overload too much of like to the users about I guess the content, but we still want the users to kind of trust the results of our models and data. So I'm like thinking, because like some of the comments is completely correct. Like one of the comments was about like for example, like FELiX is a global model and we are making projections of biodiversity. Yeah, that is true. I completely am with you on this. But a lot of this are, kind of based on assumptions. And like, if we are doing it as part of research, we normally have a lot of like set of caveats or assumptions that we can display. But I'm not sure whether it's something that, pushing it to the users, it's, just based on more explanations, is definitely going to help with the users trusting the model. So is there any way that, I don't know, is there a way for us to balance it such that we can also, provide this information in an accessible way and increase a greater trust for the users in the models that we have? Like, does anyone have any thoughts about this, especially if you're considering using it for your own users, like education or facilitation? Do you have any thoughts about this? Yeah, it does be. So for trust, it must be explainable. So I believe you're more in support of having the information somewhat accessible on demand. Okay. That is fair. That's a fair statement. Okay. Yeah. Thanks for the response. Yeah. Okay. That makes sense. I think in the FELiX simulator, like the ISE that we have, I've forgotten to introduce this, but we had a little like book icon in the input page. There was actually like, if you click on it, there's an extended description with all the citations and everything. But yeah, I think I completely forgot to explain it. But we are also trying to find ways to, I guess, put more scientific data, like, to find ways to at least show that there's a citation behind what we are trying to project. So in some sense, at least it's traceable to, I guess, like at least there is some sort of rigor attached to the projections that we have. So yeah, we are trying to also work on that. Thank you for the comment. Maybe another question, like one. Oops, sorry, there's another comment. If you have some small acronyms, To clarify, what are the acronyms? The interface that refers to the source. Could you clarify what those small acronyms mean? Sorry.
Yeah, I'm unmuting myself. Hopefully it will be quicker than type it. I just mean simply if you put it will have to be small because there is a lot of information in the interface, but if you add where the information for each of the categories comes from, for instance, if it comes from IPCC, put IPCC data, or if it comes from I don't know, MIT, whatever is the source, you can explain the acronyms and take the user to the acronym meaning somewhere else, but at least that they have the visibility that you are not creating the data yourself, that you have a source of information that is reliable behind the data. So some idea of where the data are coming from in the interface, it helps.
Okay, that makes sense. Yeah, that's a good advice, actually. I'll try to find a way to embed it more into the text. Yeah, it's a good one. Yeah. A one-pager intro which explains what the tool is for, typical use cases, what the inputs and how it processes. Yeah, there's a good... Thank you for your cooperation and your willingness to be the guinea pig. But yeah, I think there's a good idea. Actually, right now, we are trying to write a report and also maybe a manuscript on something that is more focused on exactly what you write, which is what kind of use cases, what kind of scenarios that we want to do, that also documents more in terms of what goes behind the model, so that people can at least, look at it, understand the assumptions, and also use it for their purposes. Yeah, you're right. We are all going to work on that too. Thank you for that. Yeah. Yeah, and I hope that I don't know, like I think someone previously mentioned about having like a Slack or I mean, I'm quite happy that you see a future where there's a bigger community where people will be more involved and more excited to participate. And I hope that if someday when we reach that point that it's going to be used for a lot of purposes, maybe a Discord or a Slack channel would be really nice to ensure that there's always a channel for people to ask for direct feedback about their ideas and also kind of participate in the code design of the tool. Yeah, so yeah, this is something we can look into in the future. Yeah. Yeah. Yeah, of course. Yeah. To be informal, yes. Maybe one more question about the FELiX tool. I would like to ask most of like your experience, because in our case we tried, instead of the conventional way of creating scenarios, which is based on numbers and options, we tried to use something a little bit more novel, like creating the survey function. So it's like, this is something that I guess we wanted to try something a bit more novel, because like I think if we give them a set of buttons and a set of like diets with specific names, it might be actually quite hard for people to get. So we wanted it to be a bit more experiential and reflective, where when we give you questions, you can also think carefully about your behavior and your lifestyle, and that's why it comes in the form of the survey questions. But we also run into the issue where like there are a bunch of diets, like the range of people's diet is very, very wide, and we are also a little bit afraid of putting like way too much questions to make so there is a trade-off between I guess what is easily accessible for people to answer, and also the precision and accuracy that comes with that translate the questions into the specific scenario. So yeah, so I think most likely, like I got a bunch of nice feedback from everyone, which is like, we need to think about the interactions between, like, I guess, diet and alternative proteins. Like I didn't give an option, for example, to explore, I guess, like saying no to lab-grown meat. Yeah, I don't think that I actually put those questions in, so I'll try to expand upon it. And do tell me if you think that this form like will be better in future. Maybe we can have another feedback session in future to ask you about how you guys might think about the way that we conduct this survey function. Yeah. Is there any other points of discussion? Sibyl, you're muted. Okay. I think if there are no other questions, like Nicholas, do you think we can end the session?
Yes, definitely. If there aren't any questions, we can end the session. Thank you very much for joining our webinar. And we will keep you posted on social media about the outcomes after analyzing the results. Thank you very much.
Thank you.
Thank you, everyone.
Thank you.
Goodbye.
Bye.
Thank you. Thank you. Goodbye.
Bye.